This is Elementary and Intermediate Algebra, Chapter 3.5, the last section of Chapter 3. What you need to know in this chapter, you need to know rate of change, understanding how slope relates to rate of change, and how to find the equation of a line from a set of points. So rate of change is how much change there is per one unit of another variable. For example, if a car is accelerating, we can model the change in speed as a rate. If the car accelerates from the standstill to 60 miles an hour in 6 seconds, what's the rate of change? We can turn the speed into a ratio by dividing it by time. So 60 miles an hour divided by 6 seconds is equal to 10 miles an hour per second, which means that the car increases its speed by 10 miles an hour every 1 second. This is called rate of change. So how to calculate rate of change? Calculating rate of change is identical to calculating the slope of an object, assuming that the two objects or variables are linearly related. Why? Rate of change models this change in one variable per change in the second. So slope does the exact same thing. The formula is the same. y2 minus y1 divided by x2 minus x1. And it's important that the independent variable goes on the bottom and the dependent variable goes on top. Let's calculate rate of change. So the amount of fish in the lake is 1,000. After 5 years, the amount of fish in the lake is now 2,000. Calculate the average rate of change in the amount of fish in this lake over the 5 years. So let's first know which one is our independent variable. So time is our independent variable because the amount of fish in the lake depends on the amount of time there is. So let's take x2, which is so we know that unfortunately they don't give us unfortunately there's no initial year, but we know that the change in the amount of years there are is 5. There's been a change in 5 years, and we know that there's been a change in the amount of fish. So that we know that after 5 years the amount of fish there is 2,000. So let's put this on the top, minus the amount of fish initially, so it's 1,000. So we get 2,000 minus 1,000 is equal to 1,000 divided by 5. So we get that there's a change of 200 fish per year. What does this mean? This means that after every year, 200 fish, that every year there are 200 more fish in the pond. The thing with rate of change is you don't actually need to have the beginning or ending quantities. You just need to know the amount of change there is. So in this case, we need to know the amount of fish in the lake in order to find the change in the amount of fish. But if they just told us that after 5 years there's an increase of 1,000 fish, we wouldn't even need to subtract 2,000 and 1,000, if you get what I'm saying. All we need to know is the amount of change in one variable divided by the change in the other variable, which is why we didn't even need to know when after what year was the first year. Yeah. Using rate of change to model situations. If the amount of cars sold at a dealer increases by 100 every year, and the dealer currently sells 50 cars a year, write an equation that describes this relationship. Let t be the amount of years after the current year, and x be the amount of cars the dealer sells that year. So you want to write an equation that describes the amount of cars that it sells. So you want to set x, the amount of cars they sell, equal to something. We know that initially the dealer sells 50 cars a year. So there's 50 cars a year sold, regardless of what happens. We know that the amount of cars sold increases by 100 per year. So the total amount of cars sold depends on the initial amount of cars plus the change in how many cars are sold per year. And we know that the change is 100 per year. So we call this 100 times t. Notice how this is very similar to a slope equation. And that's because rate of change is identical to slope. They are the exact same thing. So we have an equation now. X, the amount of cars the dealer sells, is equal to 50 plus 100 times t. You can also create an equation from a set of data points. So a trick here is to find how much change there is per 1 unit of one variable. Sorry, that sounds kind of complicated. But really, we're just finding the slope. So we know that this right here, we can tell that there's a 1 unit change in x, but there's a 2 unit change in y. And we want to make sure this is consistent. So there's a 1 unit change of x, 2 unit change of y. So we know that basically what this means is every time x goes up by 1, y goes up by 2, which means that the slope is 2. There's a tricky point here. Here the x value goes up by 2. So you might think the slope is wrong. However, the y goes up by 4. So in actuality, every time the slope went up 1, the y value went up 2. And the slope went up, the x value went up twice here. So the y value will go up 4 times. So the slope is actually correct. The slope is actually 2. So we can write our equation. Y is equal to 2 times x. And we just need to find our y-intercept. So where x equals 0, y is equal to 2. So plus 2. Our equation is y equals 2x plus 2. That is it for this chapter. Thank you for watching, and I hope you learned something from this video.